for coming to my talk. I'm Chase Granberry. I'm an engineer at Supabase, and I'm going to talk about caching with the Postgres write-ahead log and busting your cache with the Postgres write-ahead log. Since we're talking about databases, I figured I'd do a little poll. Has anybody dropped a table in production? No? Yes? All right. We're all family here. Good deal. Yeah, good deal. Cool. A little bit about me. I founded a marketing software company maybe like 15 years ago. It was software as a service. After that, I bootstrapped Logflare, which is kind of like a centralized logging service for about a year and a half. And then I was trying to get Supabase on as kind of like a large client because they didn't have logs yet. It was a newer platform. They seemed to be growing pretty quickly. In those discussions, we ended up coming to terms. Supabase bought Logflare, and so I'm now at Supabase full time. Logflare is still its own thing. It's going to remain its own thing, but it also powers logs like inside of Supabase. And so I do basically, I'm kind of in charge of like observability stuff and do a lot of Elixir at Supabase. A little bit about Supabase. It's a hosted Postgres product, mainly targeted, at least initially, at front-end developers. You get a full Postgres database. You get Postgres, which is like a RESTful interface on top of your schema. You get storage interface, which is kind of like a proxy to S3. You get authentication, so you can do like Google Auth or any like Magic Link Auth, all that stuff really easily as a front-end dev. But then you also get real-time, and real-time is a feed of your Postgres write-ahead log sent to you over WebSockets, and this is powered by Phoenix channels. And so the main stuff, the rest of that stuff, the main stuff at Supabase that's Elixir is the real-time product and then the logging product. And so the logs we ingest basically Postgres logs, but then also logs from lots of other, like all those other services. And then we allow people to do arbitrary SQL queries on those logs. And real-time, quick overview, started as like kind of like a single tenant thing, and it just was dumb and just sent the WAL to everybody. Almost a year ago, they launched real-time RLS, which is conscious of row-level security, and so it'll only send you records that you actually have access to according to your row-level security policies. And then recently, just a couple weeks ago, we launched basically multi-tenant real-time, and in addition to that, we call it like multiplayer edition. So we're essentially offering like presence and Phoenix presence and channels like as a service for front-end devs, so that we can enable these features for front-end developers who don't want to deal with like hosting anything. And yeah, we launched that a couple weeks ago, and all that's going to be pushed to the real-time repo and open sourced very soon. Yeah, this is kind of like the Supabase interface where you can search your logs. I think it looks kind of cool. So why would Supabase want to run its own and write its own logging service? Well, if we look at outsourcing logs at the volume that we're doing to somebody like Datadog, this is essentially what it would come out to. We ingest about 1.5 billion logs per day, so 45 billion a month. That would end up ultimately costing us about $75,000 a month, and that's actually on the annual like contract. That's not even like a monthly deal, and that's only with 15 days of retention, which is not ideal. And we're growing. Next year is probably going to be like 5 to 10 times the volume that we're doing right now. So, when you talk about building or buying, this is the kind of scenario where you definitely like want to invest in your own build. So yeah, we don't want to pay Datadog. So this talk is really about like how I scaled, or one of the ways that I was able to kind of scale Logflare. Yeah, it peaks, it's very like peaky traffic. We do about 15, well, we peak at like somewhere around 30,000 log events a second, and those are batched. And so, kind of goes, it gets to about 5,000, a little over 5,000 like actual requests a second. We have 3 to 6 nodes running at any given time in a cluster. We actually have over 100,000 processes on each node running. And one of the first issues I ran into with scaling Logflare was just, we were making a lot of database requests. When you submit logs to Logflare, we have to like authenticate the fact that like you're allowed to actually do that, you have an account. And so to do that, we need some information from the database. So we had to do a database query, and doing a database query like 30,000 times a second is not ideal. So even though Postgres is like very, very fast and amazing, you still have to go over the network. So we don't want to do that. So how do we not do database queries in our hot paths? And we essentially just want to cache everything. And my first attempt at this was just a simple cache with like an expiration on it. So we'd cache the database record, and then it would expire in 5 seconds, and then we would cache it again. And then the second attempt was, what if we use the write-ahead log? Because we have the write-ahead log, and so what if we cache stuff, and if we get a new record from the write-ahead log, then we know like exactly when to bust that cache. So this was the second attempt, and it seemed to work pretty well because we're still on a Postgres instance that costs us like roughly $200 a month, which is pretty cool. So how do we actually do that? I started with the CacheX library. I really like the CacheX library. ETS is just implementing a key value interface on top of ETS is fairly simple, but the thing that's a bit more complex is like the TTL is like limiting that cache, and CacheX gives us these settings, and you can set the expiration. So the expiration will basically expire each cache entry at some time period that you define. And that was my first like implementation. But then you can also limit the size of the cache in terms of number of entries. So you can limit it to like 100,000 entries or something like that. And then CacheX has background processes to maintain that for you. So I like CacheX quite a bit. So what are we actually caching? We're caching, this is like the user, and we have 2 main like functions to get the user. Mostly like a get by and then preload all the other stuff that we need. And the get by would be like an ID or like an API key to get the user. So we get a user record, but then we have this like context cache thing, and what this does is it implements like a read-through cache. So what we're doing here is we're taking the, we have the cache name and then the cache key, so we're caching by essentially the module function arity and like arguments. And so that's our cache key, and then our value is going to be like our user. And the CacheX.fetch, it helps us implement like a read-through cache. So CacheX will look at this cache and for the cache key, and then run this function. If it finds an entry for the cache, then it will return that entry. If it doesn't find an entry for the cache, it will run this function and then return the response of that function, and then cache that result. So no matter what, we're going to get a user back. We might get a user back from the cache, or we might get a user back, but either way, we'll know our user will be cached with the CacheX.fetch. So it's a pretty easy way to implement like a read-through cache. And then we're doing some other things here that I'll get into because we have to create like a reverse index because of the data that we get from the WAL. So this is our reverse index, and so we're basically taking So the application pulls data from essentially by a module function arity arguments, and then we get the value. Like that's how it looks up the cache on the application side. But then on the WAL side, we only get individual records, and so we have to then look up the cache. Then we have to like know what to bust by just these individual records. And so what we do is we take so we basically create a reverse index on the values that we're caching, so that when the WAL comes in, we can look up that reverse index, and it's going to return all the keys that that would return that value, and then we can bust all those keys. So this is basically what does that. It like indexes all the it creates a reverse index that we need, and then when the WAL comes in, we run this bus keys, and we have the context, which is essentially like users, and then the ID, which is the ID of the record. And then this is like not, the stream.h is like probably not the best way to do this. I wrote this like over a year ago. So we have like a really write-heavy workload. This is probably should be implemented a bit differently. But it's been working well for me, and so it essentially returns all the keys that I know I need to bust, and then I can go through and I can bust those, and then I can bust also like the reverse index. So this is what lets me actually delete all the cache entries that I know I need to delete when we get a new record from the write-ahead log. So yeah, just to kind of review, like the reverse index, the application needs to look up stuff by module function arity arguments, but the WAL, when it comes in, you need to look up stuff by the value that get returned from that. So you have to create like the reverse index based on the value that you're getting from the write-ahead log. So now that we have all that in place, we want to listen to the write-ahead log. The first library that was out there to do that was a library called Canifile. It's a great library. It comes with a lot of stuff included. It decodes the WAL for you. It sets up the connection. The only issue, well, I've ran into a couple issues with it. It uses EPG SQL, which is like an earlier Erlang connection library, and I haven't had any issues with it, but anecdotally I've seen reports of it kind of being jittery and reconnecting like maybe more often than it should. So I highly recommend just at least taking a look at it. Somebody probably should maybe kind of rewrite it to use this newer Postgres replication connection. So Jose recently, I think not even a year ago, but he added this Postgres.replication connection behavior, and you can essentially set up a gen server that will listen to the WAL for you. It doesn't do any of the fancy decoding, but it sets everything up, and then you can actually see all the messages that the WAL sends. And so it's nice to have that kind of built into Postgres at this point. But the cool thing is that the guy that wrote Canifile, created a separate library for PG output decoder called PG output decoder, and that will help you actually decode all the messages really easily into structs. So that makes it much easier to deal with the binary messages you get from the write-ahead log. And then I did put together a demo with the Postgres replication connection and the PG output decoder, and kind of tied it all together so you guys can see, and that's up at my GitHub repo. That's right there. Some tips that I ran into during this whole process. So when you set up the database, I have this, the migrations are here. So when you set up the database, you set like the WAL level to logical. There's physical or logical. Physical is it replicates the disk bytes. Logical, it replicates just the records. There's benefits and kind of downsides to both of those, but for this case, you need logical. Max WAL senders and max replication slots will, if you have like a large cluster, this is going to limit like the amount of actual connections. So you can set that. The default is 10, but if you have a cluster that's larger than 10 nodes, then you want to change that. It's recommended that you create like a replication user that's separate from your traditional user, because the replication user has pretty significant privileges on the Postgres side. So just being able to see and account for what the replication user is doing, it's recommended that you create a replication user. And then finally, you create the publication. So you create a publication, and then when you set up the connection, you create replication slots, and the publication replicates the WAL to all those replication slots, and then the replication slots replicates to the subscribers of those slots. But the important thing is, and the slot type is temporary in the Postgres connection example. The replication connection example, it's temporary, but in Canifile, it's kind of like not the default, and it's kind of briefly mentioned. But basically, a temporary replication slot, Postgres manages that for you. If you disconnect from the slot, it essentially drops the rest of the WAL. So if you don't need every entry like if you don't really need a consistent WAL to your nodes, then you really want to do a temporary replication slot, because otherwise it could potentially, like, if you don't connect to that slot, if there's nothing connected to that slot, if it's not temporary, then the WAL will back up into that slot, and unless you have max slot WAL keep size set, then it will end up blowing out your disk, because it will keep the WAL essentially forever. So you want to do temporary replication slot and or do the max slot WAL keep size to make sure that your write-ahead log doesn't blow out your disk. And then there's another thing. You can do replica identity full, and that will send you not only the new record for the record that changed, but it will send you what the old record was. And so if you want to, if you're only concerned with certain fields that may have changed, then you can use that to kind of compare which fields changed, and only send the WAL, only do what you want if certain fields have changed. And then if you have a really write-heavy workload on some table and you don't need the changes for that, you can set the table to unlogged, and then the changes from that table won't get distributed in the write-ahead log. I recently ran into this because I had a fairly large table and I was deleting a bunch of stuff from it. And this is the only other issue that I ran into with the Canifile library, is that, so I deleted 1,000 things, and then I deleted 10,000 things, and that all worked just fine. And then I deleted a few million, and that actually worked just fine. So then I kept deleting a few million, and then I was watching the server and kind of had some CPU spikiness going on, and basically it backed up the message queue with 40 million things in it, and whatever Canifile is doing to distribute those messages, it's not doing it very efficiently, because those got backed up really quickly, and this process is taking up 13 gigs of memory. So just be careful with if you have a write-heavy workload, just really make sure that the path for whatever you're doing with the WAL is very, very efficient. So yeah, I ran through the migrations. So now I'll kind of run through the demo that I did that you can find at, how much time do we have left till 11:10? Is it 7 minutes? Yeah, okay. So I'll just run through this really quick because I do want to have some time for questions. But this is the replication, connection, behavior, and this is pretty much the example that's in the documentation for replication, connection. I'll kind of point out where you define the replication slot as temporary. Again, that's in the example, so that's fine. You should probably keep that way. And then it's starting the slot. So this is exactly what's in the example, and just the only thing we're doing differently is in here. I created a separate process to actually distribute the messages, and so then I have this replication publisher, and the replication publisher just handles all the messages. There's this is the one where it really handles all the so it just handles all the messages, and then it broadcasts them over PubSub. The only thing that's odd is when you first subscribe to the replication slot, the first message from a table, you get before that message comes in, you get the relation, which is essentially it tells you what the schema of the table is. And so, to basically create a record here from the tuple that you get, you have to hold on to all those relation messages, and then find the right one so that you have the field names for your object. And so then I just broadcast those, and for the purpose of this demo, I've just subscribed to them on a live view page, and this is working. So, and then I'm just putting you'll see an ID for the record that was deleted show up here, and so that was the record that I just deleted, and that was me getting the WAL, and putting the record there. And then we also have, so we can create a few records. This should have, of course. All right, that's created. Of course I broke the demo somehow. But the deletes should still work. Well, this is the demo gods definitely not smiling on me. Well, my deletes work. But yeah, so this is essentially how it should work.